Okay, I wanted to go over a couple of the parts of the strong acid-base titration with you, just so I made sure you're understanding what's going on. Part A, they give you a couple of pieces of information. So if you look down here in the corner, you're going to see that we've got 50 mils of 0.2 molar nitric. Now, a couple of things we notice. Nitric, this is a strong acid, hence the title for the worksheet. Alright, therefore we know that it completely dissociates. There's no Ka. So in order to find the concentration H3O plus to put it into the pH equation, we only need to know the concentration of HNO3. So what we've got is we've got pH equals the negative of the log of the concentration of H3O pluses. So now here's the trick. You don't even need the 50 mils because this is the concentration of the acid. So therefore this is the concentration of H3O plus since it totally dissociates. Therefore our answer is simply negative log of 0.2, whatever that is. So that's all there really is to A. Now as for part B, we've got a little more going on. In part B, you've added acid to base. Now in this case again, strong, so we've got nitric plus sodium hydroxide goes to water and spectator ions. Really, you could write this as H plus plus OH minus going to H2O. You could write this as H3O plus because this is a solution of HNO3. Therefore, it is really H3O pluses and NO3 minuses. All right. So that's over here. This states that there is still 50 mils of 0.2 molar. So we've got 50 mils, 0.2 molar solution, and to that we're adding 10 mils of 0.1 molar hydroxide. All right. So we can then calculate our we can calculate moles, or we can calculate millimoles. Me personally, I would prefer to say that that is 10 millimoles because it's 0.2 times 50 or 2 times 5, and this is 1 millimole. Now it's just as accurate to say that there is 0.010 moles and 0.001 moles, but I don't like all the zeros, truthfully. So what I would prefer to do is use millimoles. So the purple there is our I. Now we want to do our change in our equilibrium, or our final. So in this case, since this is strong acid, strong base, total reaction, no equilibrium. So it's really a final in this case. So what we're going to get is, since this is clearly limiting, we're going to use up all 1 millimole of this. And since it's 1 to 1, we're going to use up minus 1 millimole of this. So our finals are going to look like this. We're going to end up with no hydroxide, effectively. There'll be a little bit because of the Kw in equilibrium in water, and there'll be 9 millimoles of H plus. Now, to find our equilibrium, our final concentration, we've got to make sure that we notice there is a change in volume. So you've got to take note of the fact that it's 50 mils plus 10 mils, so therefore it's 9 millimoles in 60 milliliters. Whatever that is. 9 over 6, 1.5, so it's 0.15 molar. Now, had I done it the other way, had I worked with moles, let's do it in blue, had I worked with moles, I would have had 0.009 moles in 0.060 liters, which is the same thing. It's just divided everything by 1,000 to work in moles instead of millimoles. So the takeaways here, you still set up your ice table. You make sure the amounts that are the change, since it's strong, anytime we're adding strong to strong or strong to weak, all of that's going to be used up. if there's enough of the other to react with it, and then we can figure out from our new volumes. If you have any questions, let me know, but I thought it'd be helpful to have this.